Okay, so I'm already recording and we are good to go.
Alrighty. I will fire this thing up after I close a whole lot of windows. Just a moment. All right, everybody. How's it going? Good to see you all. Thanks so much for coming to hang out. Hey, we're gonna have some fun today. This is, I guess, the third in a good trilogy of a couple workshops that we've been spending some time with Abraham Arangaran from 7A Security. He's in the back probably making fun of me and how I tried to pronounce his last name. But hey, we're gonna dive into hacking Electron apps, desktop applications written in JavaScript, and get into some very, very cool stuff. Hey, this, again, as a reminder, is totally free. I love to celebrate Abraham and all the great work that he does because of his attitude and mindset and philosophy, like, hey, let's get education out there and make it free for everyone. So I hope we're good on audio. I hope we are good on visual, but I will be tracking in the chat, and I'm going to take a back seat for this one. Abraham, this is his stage. This is his spotlight. So without further ado, my friend, I will kick it over to you, if that's all right.
Sure. Thank you for the introduction. Hopefully you can hear me well as well.
Looks good so far.
Cool. Then let's get started. Just a quick mention that we are bringing the John 50 discount back. So if anybody is considering the free stuff, you can get 50% off any course on the store7security.com. And if you're only interested on the free stuff, you can go to 7security.com/free. And we have there like 4 free workshops and some free reports as well about random stuff, so you can check that as well. So all the vulnerable applications that I'm going to demonstrate today, as well as the slides, a 1 hour and a half recording of this workshop, and so on, this is all available for free here. If you want the slides, if you want the vulnerable apps that I'm going to demonstrate to try these exercises on your own, this is all also available for free. Just go to 7security.com/free, and you can get it all there. Okay, so with that, today we will start with a brief introduction. Then we will pretend that you have maybe no idea. Some of you probably have no idea about Electron security. Where do you start? So I'll give you like some essential techniques, some initial pointers about how you can get started. And then we will talk about XSS, right? Because XSS gets very interesting in the context of a desktop application. And then we'll see how to turn XSS into remote code execution. And then 2 other interesting remote code execution scenarios, one attacking Preload script and another one using inter-process communication Ipcs that I will talk about in a second. So I'm Abraham Arangaran. I'm the CEO of 7A Security. We do training. I'm the co-author of the mobile web and the desktop app security, the JavaScript Desktop apps security course, which is the Electron course that is kind of related to this workshop. Yeah, we have delivered training at Black Hat USA, Hack in the Box, OWASP Global AppSec, LastCon, 44Con, Hackfest, NullCon, DeepSec, and many others. In May, we were at NullCon, NorthSec, and next month we will be in Korea, Hack in Paris, then the CIFCon in Gdynia in Poland, and yeah, and there's like other ones coming up. Yeah, and then I'll be again at DeepSec in Vienna in November. There's also something in Lisbon, I think. But anyway, you can go to the 7security.com/training and you can see it there. So I've done stuff for Q53 version 1. I wrote a course for illness security a while back called Practical Web. I'm the founder and one of the project leaders of OWASP WTF, which this is a free and open source OWASP projects. So if you're interested in that, you can go to owtf.org. We have 2 students for Google Summer of Code this year. So they will be making more progress and making OWF cooler. So you're welcome to, try it out and maybe send a pull request and help out make it better. This is my slide share, and I was a developer first, then I switched to security. So this explains the random certification variety. But the truth of this is that if you're a developer, I got your back. I know your point of view. I know the frustration of pen testers when their issues don't get fixed, and the frustration of developers when it has to be working on Friday in production, right? Or with all these deadlines and stuff. I also know that part. So this slide is about some interesting reports. So this is another way to learn about security for free. There's a lot of public reports available for free on the website. So the first half of the slide is about Smart Sheriff. This was an application mandated in the entire country of South Korea. So by law, every parent and child was forced to install this. And it was basically so bad that we even gave a talk about it, right? So if you search on YouTube for Smart Sheriff, some idea, you can see a talk about it. The 2 pen test reports are free there. And there's an application, there's a new public pen test report coming up. I don't know. There's some politics now until we can release it, but it's similar to this, right? So more about that soon. And then there's the Chinese police and Cloud Pets that you can also watch on YouTube. So BACQ is an application that the Chinese install in your phone when you cross the border, especially to a region of China called Xinjiang. They grab your contacts, your SMS messages, what applications you have installed and stuff like that, and they upload it to a police server. My job is more for the police officer manually. And then Study the Great Nation is kind of an interesting concept where the application is not mandated, but it is encouraged, because the more you know about the great leader of China, the more points you get, and with these points you can do cool stuff in China, right? So the concern here is the application spying on users and so on. So there was some analysis on that. And the upcoming report that we will release very soon is kind of related to this kind of stuff as well. So there's a little bit of security like in Smart Sheriff, a little bit of privacy stuff like this, right? So that's coming up soon. We also released like a couple of, like last week, I think, this pen test report. So this is interesting because it has mobile, web, and IoT stuff. So very cool concept for helping people in operative kind of countries where the government censors the internet. So they basically have, it's a cool open source project where they give you, like the person that is in a free country has like a small router, and then with this router you can share your own internet with family and friends. So yeah, and then there's like a mobile app and there's like a web component to this and the IoT device itself. But the cool thing about it is because it is like regular people in free countries that are providing internet access to people in censored countries, it is very difficult for a censor to block this, because now it can be like basically any IP on the internet, right? Any kind of private user can be doing this. So it's a very cool concept, and we pen tested it, and there's some interesting findings there. So, okay. So the hacking JavaScript desktop apps course, as well as by extension this workshop, was made cooler thanks to these 3 people. So I'm just going to give full props to them. Masato, if you don't know about him, follow him on Twitter. Very recently, he got, I think, $150,000 in Tencent West for hacking Microsoft Teams, which is completely related to this workshop, because it was the Microsoft Teams Electron app, right? So you can search on YouTube for Masato versus Microsoft Teams, and there's a cool video about that. Kaido is the #1 ranked person on Twitter for bug bounties, I think. At least he was for many years. I'm not sure if he still is. And Interscript has done a lot of PDF research, and basically they're all friends of mine, and we do like stuff together and so on. So just to give them thank you here, because they helped with their answers, insightful answers, made the course more interesting. So this will be if you are interested in taking the course. So in this, I just say that both VirtualBox and VMware both work fine. Now the first 4 points are true in kind of all, like whenever you purchase anything, did you kind of expect this, right? So you get digital copies of all training material, lab VMs, test applications, source code. So this is all kind of normal. And what we do a little bit different is this point 5. You also have lifetime access to training portal, which includes all future updates for free, step-by-step video recordings, slides, and lab PDFs, and unlimited emails and Slack support, right? So whenever you have a question, you know, even if it's months or years after you bought the course, we will be there to help you out. So with that, now I'll touch very briefly on what the course covers, focusing more on what we will be talking about today. So we start with an introduction. So from this today, we will do a bit of this, so a bit of package detection, web preferences, how that works, a little bit of finding vulnerabilities in dependencies, XSS exploitation, what happens with node integration, and remote code execution mitigation essentials for Electron applications and Electron negativity, right? So we are going to see a few things from the intro because we kind of need to explain a little bit of the intro, right? Now, of course, we cannot cover all this, but I'll give you a taste of it. And from this, we will be attacking preload scripts. So this will be very interesting. And also, we will use a cool technique to get remote code execution without warnings windows. Then Electron apps, since they work on Mac or on Mac, Linux, and Windows, they have the same vulnerabilities as any other, can have the same vulnerabilities as any other desktop application, right? So we also look for file system leaks and other stuff in the course, but won't be that today. There's a lab dedicated to man in the middle and the different tricks on all the platforms, how to force the application to send you the traffic when it doesn't want to. Then the art of repackaging is interesting because here we modify Microsoft Teams, Slack, and other well-known apps at rest. We make some changes, and then, you know, this can be very useful sometimes when you are like debugging and so on. Instrumentation, we change the application at runtime. So there's some techniques we cover here with FIDA Discover, Defron, Chrome Inspect, and so on. So it's also interesting, but we won't in that today. Then there's a CTF where you practice your skill kind of more open lab. And then in part 2, we cover more advanced scenarios, right? So from this, we will be doing a little bit of using file URLs to get code execution today. Then there's another one about data exfiltration. So how can you read local files and send them to an attacker? And this will be a topic for today, how to gain remote code execution through Ipcs. So this is going to be very interesting, but I won't get ahead of myself. Then we revisit man in the middle with other scenarios. Then remote attacks, this is a very cool lab because actually, even though we call these hacking JavaScript desktop apps, sometimes it can happen that a web application runs an Electron component. Then all the techniques to hack Electron applications can be used against in a web pen test, right? So you can sometimes hack the web server by using the Electron hacking techniques, which is pretty cool, right? So there's a lab dedicated to that, and then another one about privilege escalation and so on, and then there's another CTF after that. So, okay, so let's pretend you have no idea about Electron applications. So where do you start, right? So let's give you like a quick crash course, right? So first question you might have in your mind is, okay, JavaScript on the desktop, but why do it, right? So traditionally, you have, if you are a company, right? So you think, put your CEO hat for a second. You're a company, you normally, historically, would have to have 3 developer teams, one for Windows, one for Linux, one for Mac. So these are completely different development skills, different tools, different licenses that you require for software licenses and so on, right? So a lot of costs here. You need to pay 3 development environments, 3 different teams. You have to coordinate the teams between each other. Maybe this team has a nice idea, and then the other teams have to implement the same thing in their platform. So these all, you know, you're basically spending a lot of money with this, right? And also, there's fewer people that can develop Windows, Linux, or Mac applications compared to JavaScript, right? So a lot of web developers can develop in JavaScript. So the cool thing about Electron is that since you can develop in JavaScript, you can potentially find more people. It's going to be easier to find developers because more people know how to develop in JavaScript. So that's the first. Then you only have to pay JavaScript developers. So you only need one development team instead of three. And then you don't need to coordinate the different teams because there's only one team. And then the app magically works on everything, right? So Windows, Linux, and Mac. So it is pretty cool, and this is why a lot of companies are doing this, right? So it makes complete sense from a financial point of view and logistics as well, right? So the next question you might have in mind is who is really using this, right? So is this like randomly used, or are there like some big players using it? So you can see here, maybe you recognize some names, right? Microsoft Teams, Skype, Zoom, Slack, Discord, BigGarden, GitLab, Signal. There's a lot of applications using Electron that are quite well known, and many of these we use in the course itself as well. So that's you know, all the vulnerabilities are either recreated from pentest or we use like a well-known public application as well. So the next thing to understand when you are testing Electron applications is like, let's pretend like this is the Discord icon of the Discord Electron app, right? So you click on it, and then the first thing that is going to happen is that the main process starts, right? So the main process is kind of controlling everything. It is more powerful, it can do more things, but it is less exposed to the user, right? And then the main process at some point, it will create a window, right? So the window is what the user interacts with, and this is more sandboxed. It's kind of a little bit easier to protect through security settings, but at the same time, it's more exposed to the user. So most of the time, this is where the XSS is going to happen. And this is all controlled in what we call a renderer process, right? So for each window that the application shows, most of the time, it will be just one window. This will be the renderer process, right? So a renderer process, more exposed to the user. Normally, what is going to be attacked is this. Main process more privileged, less exposed to the user, but if you have a problem here, it is a bigger problem because this process basically can do anything, right? So you have the kernel, so you have Windows, Mac, or Linux, so you have the operating system. The operating system will have a kernel, which controls the file operations and so on. And then there's an abstraction layer with Electron, which will be talking to the kernel itself, right, through API calls, right? So this is the cool stuff about it, that you abstract the operating system and you just develop in JavaScript. And then there's going to be the main process, which is going to be calling APIs, Electron APIs, as well as the render process, which can also call Electron APIs. And the main process and the render process can talk to each other through IPC messages, right? So IPC stands for inter-process communication. So this is just a fancy way of saying they can send JSON to each other, right? So you can have an event listener here, and then this can send a JSON message to the main process with some, some JSON message, and then the main process is going to process that. So this is one of the things we will be attacking today at the end. So main process, more privileged, can do more stuff. Render process can do less things, and then both processes share some stuff. Also, Electron is built on top of Node.js, right? So Node.js is basically the foundation of Electron applications. So learning how to attack Electron applications can also be useful to learn how to attack Node.js applications. In fact, sometimes we have taught this course together with a Node.js web course. So, okay, let's pretend you have no idea about Electron. Where do you start, right? So some techniques to give you like some fast findings. So first, for this exercise, it doesn't matter, you can use the GitHub link. You can also use the one on the training portal, but I'll talk about this later when this is the only option. But basically, if you download some old Electron application, right? So for example, standard nodes version 2 is very old, right? So this is going to be vulnerable to a lot of things because it's just an old version, right? So a lot of new releases and vulnerabilities have been discovered since then, and we will be able to find a lot of problems. So the easiest way to find some vulnerabilities is just to run Npm Audit, right? Now, this command is useful not just against Electron apps. You can, if you have the source code, you can use these against anything written in JavaScript, right? So basically, you can run it against mobile apps written in JavaScript. You can run this against Node.js apps for web applications, as well as Electron applications. Npm Audit definitely a super useful command for anything JavaScript to find vulnerabilities in JavaScript libraries, right? So the first time you run it, you might see an error message that will look something like this. So it will complain that there's no package lock.json. So the reason for this is that you can have a dependency that has a dependency that has a dependency and so on. So when you do npm I package lock only, which the error message is telling you, so you just have to copy and paste this from the error message. This will create the package lock.json file while resolving the tree of dependencies, right? So then when you run npm audit again, you will see like some findings here. I'll show this in the demo in a second. So an important point to emphasize here is that it's only a matter of time until vulnerabilities in dependencies are discovered and made public. So even a perfectly secure application could become vulnerable down the line as issues in underlying libraries are found over the years, right? Now for this next exercise, we will be using the vulnerable one application, which is an application that replicates many findings from multiple pen test reports that we could not make public to protect the guilty due to non-disclosure agreements and stuff. But the vulnerability itself has been replicated in a dummy application that makes it very easy for you to test these vulnerabilities and understand how everything works, right? So for this kind of stuff, any link that you see training70security.com, you need to be logged in. But again, this is all available for free, right? So you go to 70security.com/free, then you download this workshop, and then on the training portal, just download the slides. And while you're logged in, click on this link from the slides, and this will download just fine because you are clicking while logged in, right? So if you try to wget, it won't work because you're not logged in. But if you click while you're logged in, this will download just fine. So then the package.json, the main thing to look at is the main entry point, right? So one of the entries will be called main, and this will tell you the name of the JavaScript file that is going to start first. So this is basically where the main process is going to start, right? So then you open this file, main.js in this case, and here we can see that there's web preferences, and we have node integration set to true, which is bad, and context isolation set to false, which is bad, and we will be attacking both of these settings today. So why are these bad? Node integration is enabled, so node integration true. This is bad. Why? Because if you have an XSS vulnerability in the app, it increases the impact from just alert one to full-blown code execution, right? So this is why it's dangerous, right? You basically, node integration means you can invoke any Node.js API, and there's some Node.js APIs that allow you to interact with the file system, that allow you to run operating system commands. So basically, you can load any Node.js module that you want and do stuff, right? So this results in immediate code execution. So it's going to increase the impact of an XSS to immediate code execution, right? So this is why this is bad. Then context isolation, when context isolation is set to false, this is also bad because it means that any XSS that you have in the application will run in the same context as the JavaScript of Electron and the JavaScript of the main process, right? Of the application. So with this, we can mess with Electron in two ways. One way, which we will do during the workshop, is we can mess with the functions in the preload script or the functionality there. So we can redefine the functions in JavaScript so that they do something else. And then we can bypass security checks and do all the cool stuff. So this is one scenario. And another scenario is we can even send an IPC to Electron itself by abusing this lack of context isolation, right? So we covered that is a more advanced technique. We covered that during the course itself, but just to mention that it's possible. So if context isolation is set to false and you have XSS, in most cases, given enough time, you can probably turn this into code execution as well, right? So both things can result in code execution. So with that out of the way, let's give the people a little bit of a chance to say something. Does anybody see the vulnerability here? Anybody sees a problem with that?
I'll give a moment for the chat to chime in.
Sure.
So we're grabbing an element by an ID, send button. We have a on-click handler for a function. We can get the element's value. I see one message come through. Hey, no sanitization on the message, no input sanitization, setting inner HTML to a message.
Correct. That is basically the problem, right? So this is a messenger application, so users can send messages to each other. The application is grabbing the message and then assigning it to inner HTML. So this would be the user input. This is the source, and then inner HTML would be the sink. So the sink is a place in JavaScript where whenever you assign user input, this is going to result in DOM XSS. So we have a DOM XSS issue vulnerability here, right? So you can Google for DOM XSS wiki, and that will give you a full list of XSS sources and things. If you are interested in a full list of things that can result in DOM XSS, and that includes even jQuery, Angular, and other JavaScript libraries, things for those. It hasn't been updated in a while. For the most part, still quite relevant. This is the vulnerability in the render. That is the XSS issue, right? And then another tool that we will use is electronegativity, right? So JNSec is a company that basically maintains this tool. So you do npm install at JNSec electronegativity, and then very important, you want to install it globally, right? Because if you don't do this, it will try to install it locally in the directory of the app. You don't want to do that. You want to install it as a tool with the -G to install globally. And then you just do electronegativity -I vulnerable1, and this will run electronegativity against the vulnerable1 application, and it will give you some findings. So interesting here is that you get the file name, the lines affected, and then you have a link to read more about it, right? So let's do a demo about this. I believe I'm already sharing my full screen, yes. So this should work out a bit more smoothly. So let's do first the npm audit, right? So I'm running here npm audit on a very old version of standard nodes. So you can see that over the years, a lot of vulnerabilities have been found in dependencies. And because the application I'm using is old, it's now vulnerable to a lot of stuff, right? So this is one quick way to find vulnerabilities, is simply to run npm audit, right? So very simple command, npm audit. You can see here the summary: 45 vulnerabilities, 4 low, 16 moderate, 19 high, 6 critical. So, it's a quick way for you to find something, right? If you don't know where to start. Then the next thing would be to start looking at the configuration, right? So you go first to the package.json. So this is going to tell you the structure of the application. So in this case, we don't have any dependencies because it's a very simple application, but the main entry point is main.js. Right? So this is the first thing to look at, because this is how the main process is going to start, right? So now I open main.js, and in here we can see the web preferences, right? So we have web preferences. So these are the settings, and very important here as well is new browser window, right? So this is creating a new renderer process. So this is what is going to be like the window that the user interacts with. And always when there's a new browser window, so you should always grab for this when you do a code review of an Electron application, and then you should pay close attention to how the web preferences are set, because this is going to define the impact on the way you are going to attack the application, right? So in this case, we have node integration set to true. So this means any XSS means immediate code execution, and context isolation is false, which is also bad and can also be like directly code execution with XSS using some of the techniques. And then on the render.js, we can see the vulnerability here. There's an assignment of the message to inner HTML. So this is what results in the XSS, and this could be one way to fix it, right? So if you assign the message to text content, then the message will no longer be interpreted as HTML, right? Now I'm going to run electronegativity on the vulnerable1 application, and this will give us some findings. So you can see that we have here like some findings, some are tentative, others are firm. Then you have what is the affected file. So in this case, it's main.js. the lines is from line 7 to line 21 and so on, right? And then you have these links to read more about it and how to mitigate it and so on, right? So electronegativity, definitely another very good tool to give you like something to put in the report or get started. It gives you basically some leads for you to get started, right? So if you have no idea about Electron. Okay, so let's continue with this. Now, if you have XSS in a desktop application, what can you do with it and how to turn XSS into remote code execution, right? So let's see. This we will keep using vulnerable one in case somebody joins a little bit later. Just 7sql.com/free. Download the slides from the slides. Click on this link while you're logged in, and this should download just fine. Any problems? Email admin@7sql.com, and we will get back to you with solving your problem. So yeah, you basically can create some directory, and then you cd into the directory where you unzip this file. And before you start the application, you have to do npm install, right? Because I told you these are JavaScript applications that run on top of Electron, that run on top of Node.js. So even if the application itself doesn't have any dependencies, npm install will install Node.js and the relevant Electron version for which the application was written, so the application works smoothly, right? So you first need to npm install, and only then you can do npm start, right? So then this is like a simple messaging application where you message yourself to simulate one user messaging another, but much easier for you to test and figure out what's going on. And then if you have like some web pen testing background, you might be tempted to try payloads like this, right? So you can try script alert 1, SVG unload alert 1, and so on, right? So if you try that, you can also check the developer tool. So you can do Control-Shift-I or Command-Shift-I if you have a Mac, and this will open the developer tools, and then we can figure out what's going on in the application, right? So we will basically see what is happening. So if you do test script alert 1 meow, you can see that script alert 1 is not displayed, so this is encouraging. It means there's HTML injection, but you can see that there's no alert 1 anywhere. So this script is not firing, right? So this happens because since the page has already been rendered, this is like according to the RFC. If the page has already been rendered, the script should not be run. However, we can get around this by using, for example, an image HTML tag, and then the image will basically use the path for an image that doesn't exist, like X, and then the on-error handler will fire, and then we can put our JavaScript here, right? So you can do test image source action or alert 1, then you get the alert 1. Now you can see here the broken image, the HTML injection without encoding here, and this all seems fine, right? So this is just the typical XSS, and now we want to take this to the next level. So since node integration is enabled, right? So when node integration is enabled, any XSS becomes immediate code execution, because you can do this, right? You can do require tell process and then exec-sync of any command you want, right? So tell process exec-sync. Now, another tip for you here is that you want to use the synchronous functions, right? Because in Node.js and JavaScript, developers like to do things asynchronously. Sometimes if you have code execution, if you don't use the synchronous functions, even if your remote code execution is working, you might not know about it because it just runs at a different moment, right? It runs in the background before you get the response. Right? You want to the command to wait until this finishes and then return the output to alert so that you can see, right? So in the case of Genome Calculator, there won't be any output, but if you run the ID, ls, uname -a, and so on, the alert will show you the output of the command. So this will make more sense now when I do the demo, right? But basically, you can do required tell process exec-sync, or you can require the fs module in Node.js to interact with the file system. So you can do basically anything you want, right? So this is why node integration is very risky. Now, if you're a developer or you're a good pen tester that writes good security recommendations in your reports, you also need to know how to fix stuff, right? Or at least tell your clients how to fix stuff. So you should think of security in layers, right? So the more layers you have, the more difficult it's going to be to exploit stuff. And the hope is if one or two of the layers fail, you still have some other layer that is going to make exploitation more difficult, right? So one first layer of protection that you could do is to reduce node integration. So instead of having it to true to set it to false, this will decrease the impact of XSS and it will not be code execution immediately, right? So this is going to make security a bit better already. So when you do this, even though you have the broken image and so on, and you can even have the XSS, at least you will get this error message. Require is not defined, right? So require is a function that is only available when node integration is set to true, because it's the function that allows you to load Node.js modules. And you will notice that require is not defined when node integration is disabled, right? So that's the first security layer that we could implement. Then another layer of security we can add is the content security policy. So when you do image section alert 1, you can see the XSS is still there. But if you go to the index.html and you run the content security policy, and then you close the app, then you start it again with npm start, and then you try this payload, you will see this message, right? So refuse to execute inline event handler because it violates the following content security policy directive, blah, blah, right? So basically, the content security policy is now making XSS more difficult to exploit, which is also a good thing. And then finally, we should also try to fix the XSS itself, right? So the other two layers are more in case you forgot some XSS somewhere, right? So that the hope is at least that will reduce the impact, make XSS more difficult to exploit. But what you should really do is also fix the XSS, right? So this is the most important of all the mitigations. And the best way to do it would be to avoid XSS sinks, right? So for example, instead of assigning user input to your HTML, you assign it to text content, and then there's no longer an XSS. So when you try this, the payload will be rendered as text. And on the developer tools, you can see that this is correctly output encoded. So we no longer have an XSS, right? So this would be the ideal way. But sometimes the problem is that the application itself requires some HTML, right? So sometimes there's some rich text editors that allow users to use like bold, underline, and other stuff. So in those cases, you can use a library that sanitizes stuff, right? So you can do, for example, install Don't Purify, which is a library that a lot of websites use. I think there's more than 1 million installations now. It has been hammered over the years, so it's pretty good by now. Do npm install Don't Purify on the vulnerable one application that will add it as a dependency. And then you can add this line of code on the preload.js, Don't Purify require Don't Purify. And then you still use inner HTML, but you can use Don't Purify sanitized message. So this is going to allow HTML, but no XSS, right? So this would be the way to fix it, right? In cases where you want to allow some HTML. Now, a better way to use Don't Purify sanitize would be to define a whitelist of the HTML tags that you want. So for example, here you could put, I only want to allow underline, underscore, so underline, right through, and bold and italics or something like that, right? So you would allow only those tags, and then all the other tags would be refused. So that would be even stronger sanitization, right? So that will be even better. But even without any parameters, it's pretty good. If you close the application, you run npm start again, and then you try some payloads. So for example, this is an image with your handler, this is an href with JavaScript, and then you try that, and you can see that all the JavaScript stuff has been removed, even though the HTML injection is still there because some HTML is still allowed. The JavaScript has been removed, right? So that is the purpose of using Don't Purify in situations where you actually have a requirement to allow some HTML. So with that, let's do this demo. I'm just running the vulnerable one applications with npm start. I'm just making it bigger so that you can see this. And now I'm just going to go in here. Maybe I will also hide this. I'll just hide this so that it's less distracting. Okay, so you basically go you can copy these payloads, which are there on the slides as well. So I'm going to try all the payloads at once, and then I'm going to paste them here. I'm just going to make this a bit bigger so that you can see them, right? So we have the image source X and so on. Now, since JavaScript is asynchronous, you never know which is going to run first. So this is the ls command, ls.l. You can see here the output of that command. Now, this one is taking a bit longer. So this is the Genome Calculator. And because the Genome Calculator returns no output, then we will get a blank alert because there's no output from it. So I'm just going to close it. Now we get the blank alert because there's no output from the Genome Calculator. And now this is the output of the uname-a command. And this is the output of the ID command, right? And this is all because if I go here, you can see here, like there's absolutely no sanitization due to the assignment. So the XSS is turned into code execution, right? Okay, with that, let's move on to attacking preload scripts. For this one, we will be using the vulnerable to application. And another thing that I have to do is to start, I think it's this VM. So let's see if, yeah, I have that. And yeah, well, that is booting. Let me explain this. So when context isolation is set to false, which is still the Electron default, there's no isolation between the preload script and the HTML, right? So if you have on the preload script, you have window ABC equals 1 to 3, and then you do alert window ABC, you will get 1 to 3. So basically, these two contexts are the same, right? So if there's isolation and you do the same thing here, you will get undefined because the JavaScript context where you will get the XSS is independent from this context, right? So this provides you much better security. So what can go wrong with this? If the application has a security check, then we can bypass it, right? So you can redefine any function. For example, in the next demo, I'm going to redefine the index of functions. You can redefine it to bypass a security check and make it work in a different way. This will make more sense in the demo. So I'm just going to jump to it. I'll just show you a little bit here of the code, right? So what the application does is it defines safe protocols, right? So it defines safe protocols as HTTP and HTTPS, and these are safe protocols because when an Electron application uses shell open external, what it is going to do is it's going to open this link in the operating system. So if the operating system tries to open an HTTP or HTTPS URL, this will be opened in the browser, so this is safe. But if the application tries to open a file URL, then a file URL from a network location using a Java extension will result in code execution without warnings on Windows, right? So you can get cool remote code execution without warnings using this trick, and you can do like image source sectioner, array prototype index of function, return lit. So this check that is trying to validate if the protocol is safe for this link, it will be bypassed, right? So yeah, I'll just show it in the demo. I think it will make more sense. Just do it. So first, I'm going to start the application. So I think I closed it. So okay, so npm starts. Now the application starts. I'm just going to make this bigger so that you can see it. So this is the vulnerable application, and this application has a check, right? So if I go, if one user sends another user this message, hey, look at this. Now the application itself linkifies the link, right? So we don't need any access to that. And then when the user clicks on this, the application is saying this link is unsafe because it is unsafe, right? If Windows opens this, it will result in code execution without warnings, right? It's a file URL from a network location with a Java extension. This will result in code execution without warnings on Windows, right? So how is this check working? If we go to the preload.js, you can see here the safe protocols defined as HTTP and HTTPS. I'm just going to copy it from the code and put it in here. This is an array of the protocols that are defined as safe. And then the application has this check, right? So there's an event listener for clicks, and then it checks that, okay, if the safe protocols index of the protocol is different than -1, then it will be considered safe and it will be opened in shell open extern. So if I do this and I use index of HTTPS, for example, you can see that this is position 1 of the array. HTTP is position 0 of the array because things in computers like to start with 0. So this is 0, this is 1, but if I put here anything else like a file URL, it will be -1, right? So I'm just going to enter on this and you can see that this is -1. So because this is equal to -1, anything that is not safe, then the application falls into this else and says this link is unsafe, right? So that is what is happening here. I click on this and I'm getting this link is unsafe. However, we can change the index of function because there's no context isolation, right? So what we can do is we can send, hey, look at this. But now the difference is we are also sending some XSS here, image source sectioner, array prototype index of function, return lead. So this will render an image. Now this image, because it doesn't exist, you can see it's broken. It will execute this array prototype index of function, return lead. So now, if I do safe protocols index of file, you can see it returns leads. If I do the same for HTTP, so it doesn't matter what you do, right? So if I put here a lot of A's, it's going to be lead as well. But what matters to us is that specifically file URLs are allowed, right? So you can see that this is return a lead, which is different than -1. So now if I click on this link, instead of getting the error message that this is not allowed, you can see here that I'm getting the code execution, right? So this is the Java file being executed without warnings on Windows. This is Windows 10. So this will work in the latest Windows, right? So that's how it works. It's a trick that you can use even in situations when you don't have any XSS. If you can manage to fool the application somehow to open a file URL like this, it can result in execution without warnings, which is a pretty neat trick. Because I'm just going to minimize this, and then we have a bit of time to explain the last demo for today, which is going to be remote code execution through Ipcs, right? So for this one, we will be using the vulnerable 3 application. So if anybody join later, so it's /free, download the slide. From the slide, click on this, and it will download just fine as long as you're logged in. wget won't work, but from the slides, it will be fine. And then to exploit this vulnerability, we need a few requirements. First, we need an XSS. Second, we need the main process to be listening to some event that does something really dangerous. So in this case, we have an event listener for get update, which expects a URL. So in the XSS, we will try to fool the main process so that it retrieves this URL and then downloads it, gives it executable permissions, and tries to run a fake update, which is going to be basically your payload, so that we gain code execution. And then the second requirement is that the renderer process needs to expose this IPC to the render, right? So sometimes developers do this with some wrapper function like this, like window electron send of event data, and then this is calling an Electron API, right? So if node integration was disabled, on the preload script, you can still call Electron APIs. So if there's no context isolation, what developers sometimes do is window Electron send event data, and then this is just a wrapper of IPC renderer send. So what you're doing, if you do this, is you're exposing Electron APIs to XSS, right? So because now using an XSS, you can call this Electron send, so you can access the main process, which should normally not be possible through the IPC, right? So this is a reenactment of a vulnerability found in a real pentest as well. So what we will do is to send a fake update, which will be a Linux reverse shell. And then with XSS, we basically just doing this, right? So Electron send of get update, and then this will provide an update, which is basically a shell script that will give us a reverse shell. What it is doing, right? So this is all hosted here, so you can follow the exercise on your own. Now, in other cases, this vulnerability might exist in a different way. Like sometimes the developers on the Preload script might expose window Electron open in browser or something like that, which would open a shell open external URL. So this would also be a problem, because from the XSS you would be able to call shell open external directly, but you don't even need to attack the Preload scripts. You just pass the file URL to this, and then you get code execution without warnings on Windows, for example, right? Other examples could be Electron listen, Electron send, and so on. So this is all bad, because it is exposing these Electron APIs to XSS when there is no context isolation, right? So yeah, so this is basically what the application is doing. So I'll just jump to where this is more explained, like the vulnerability itself, right? So first, there's this IPC main, it waits for an update, it expects the URL, then the WDL download event will be triggered, then the file will be saved in the download path of the operating system. And then there's like some events like updated and so on. And then eventually the done event, right? So when the download is finished, will fire. And then this is just setting executable permissions for the update. And then it tries to execute the update, right? So this downloads the update and so on. And then what we can do is we can send a user a link like this. And then when they click on it, it will be this script like Electron send, get update, and so on. And then this will download the reverse shell, which is basically a Linux shell one-liner. It creates an input-output. So first it deletes it, and then it creates an input-output file. And then it cuts the file, pipes it to SH in interactive mode. You want to redirect error messages to standard output so that you see error messages on standard output. Then this is piped to netcat on port 444, which is the official port for shells. And then this is piped into the input-output file so that, like the whole loop of the interactive shell is ready. So if you do everything correctly on the terminal where you're running netcat, you will see this listening stuff. And then when you click on the link, so you basically send this link to the user, that the other user receives it, you click on this, and then you will see something like this, right? So when the application does console.log, the main process will show those messages on the terminal itself, whereas the renderer process will show those messages on the dev tools, right? So here you can see main.js complete, get update of the reverse shell, download path of home alert one downloads reverse shell, receives the bytes, and then the download is successful, it runs the update. And then on the terminal where you have netcat, you can like start running commands like id, ls, cat password, and so on. So let's just jump to the demo. Let me first close this one. And what we want to do now is use this. So this is the link, and this is just the source of it. It's just script Electron send. Let me make it bigger maybe. So you can see it's just a script, Electron send, get updates, and then it's just the path of the reverse shell. So let's just do that, right? So first we need to start a vulnerable free application. I'm just doing npm start. I make this bigger, and then you send some user this message. Now, before clicking the link, I have to double check here that we have netcat listening. So now I have netcat listening on port 444. And now if I click on this link, this opens this window. And now if I switch to the terminal, you can see connection received. So I received a shell, cat password, you name the say, ID, and so on, right? So I have a reverse shell. And how did this work, right? So if I go to the source on main.js, you can search for the IPC, right? So IPC main require Electron, get update. It waits for the update for the URL. And then here the will download event is triggered, and so on. Eventually it's done. This is the done event when the download is finished. So when it is complete, it gives it executable permissions here, and then it actually runs the update, right? So what is giving us the thing. And then if you go to the terminal where you launch the application, right? So npm start, I told you like the main process is going to show you the console log messages on the terminal itself, right? So main.js complete. So if I search here for complete, for example, main.js complete is console log on main.js, right? So this is why we can see this here, right? So first main.js is complete. Then when you do the get update, you can see that get update is called with this URL. The download path is home alert what downloads. The download URL is this one. Then this is the download path. Then it tries to download the file, which is very small. Then it says download successful running updates, right? So that is what is going on, right? So running update, you can see that this is the message right here before changing the permissions and so on, right? So this is why this works, and it's a pretty cool reversal, with remote code execution. So with that, I believe we have a bit of time for questions. So quick reminder that you have the John 50 discount for 50% of any course. So this is basically half price for everything. Now, I know now with the crisis in Ukraine, sometimes people say, well, I live in a country where my currency has trouble against the dollar now and so on. What you can do is to buy only half of the course. So for example, you can buy only Android or only iOS from the mobile course. You will see there's options like that as well. So that would reduce the price for another half if kind of money is a little tighter. And if you are interested only on the free stuff, you can go to 76.com/free. And we have slides, all the vulnerable apps demonstrated today, as well as a recording. That's all uploaded there. Yeah, available completely for free for you. And with that, we have time for questions. So are there any questions in the chat, John?
I will take a look-see. Thanks so much for doing this, as always, Abraham. It's very, very cool and a ton of fun. It looks like some folks are jumping in. Oh, looks like it came in late, right at the very end. No sweat. Well, hey, I don't know about you, but I think we've had about 200 or so folks hanging with us. Moved up and down between 175, 150, but I hope this is still great. I'll wait to see if there are any questions coming through, but a lot of the, hey, thank you. A whole lot of the, hey, this has been great. Thanks so much. Super appreciated, Abraham. So.
Welcome. Thank you.
I have one question, if it's all right, coming through. How do you detect how do you audit, Electron applications if they're already packaged and you might not have access to the source code? Is that more, fuzzing, black box testing, just trying to poke and prod?
Yeah, we covered that more during the course, but we didn't touch on that topic today due to time constraints, obviously. But basically, there's a lot of techniques for reversing. So in the course, we cover how to extract the EXEs for Windows, the Mac builds, the Linux app image format. So for example, the app image format has it depends how the application is packaged, but in almost every case, you can always extract the file in some way, the installation file for Windows, Mac, or Linux. And then you can even modify the code of the application as well, right? Which is the repackaging that I was talking about during the intro, where you can compile, so you can extract the application, you can make the application use the extracted files as opposed to the byte files, and then you can even beautify the JavaScript so that it's a little bit more readable. And then you can make changes to this JavaScript, and your changes will be the code that is actually run by the application. So this can be very useful in situations where, for example, the application is doing some code or some complicated stuff that you want to trace more step by step and to see what's going on. So it can be very useful, right? But yeah, that's explained more step by step with video recordings and everything in the course itself. But that will be the short explanation. In many cases, if you use Windows or even in other platforms, what you can do is install 7-zip, and you just right-click and extract here, and 7-zip just figures out what the format is, and in many cases, it can also extract exe files. So that's a quick trick to get started with that. But the file you want to go after is normally called app.sr. And then what you do is sr extract the app.sr. And then this extract like the Electron app internal stuff. And then this will like uncompress like all the JavaScript files and so on. And if you do that like in the right place, then the application will use those files as opposed to the packed files. And the cool thing about it is that then you can make changes as I said. Hopefully I answered the question. If not, keep asking. Are there any other questions?
No, that's awesome. So a lot of great feedback. They say that 7-zip trick is fantastic. Some folks asking, hey, does Abraham have a YouTube channel, or is that something maybe 7A Security over on YouTube might have some cool videos?
We have a channel, but we don't we don't push too many videos. Maybe we should push more. But yeah, well, when you take the access for the workshop, you will take the video from the channel. But yeah, maybe we should push them more there. Maybe I'll put this on our channel as well. So there's some traffic going on.
Heck yeah, no, I think that'd be great. All the hacking demos are very, very cool. Do you tend to proxy some of the interactions that you do when you're poking at Electron apps through Burp suites? Or
Yeah.
Someone was asking Kaido. I don't know if I know. I'm not familiar with that one. I don't know if you are. What's your opinion on Kaido versus Burp suite, or do you use one or the other, etc.?
I'm not familiar with Kaido, but normally I would use Burp. In some cases, what can happen is that the application uses some protocols that Burp is not very happy with. Like, for example, if it's an email application, it will use POP3 IMAP and so on. If it is a chat application, it can use XMPP, right? So it's an XML protocol, which also Burp doesn't like too much. But there's some extensions in Burp for this kind of stuff, like Burp Nope, so NOPE. There's an extension for it. It's a little bit tricky, but most of the time it gets the job done, especially if you have enough RAM, because it's a little bit buggy. But yeah, maybe it's a bit better now. But the few times where I encountered problems like this, it becomes fine. Get the job done. There's some tricks like this, and then I think there's some other libraries like man-in-the-middle proxy and so on when things get complicated. But most of the time, like 95% of the time, just HTTPS traffic is the norm, and then Burp will do the job. Now, the only trickery there is that what we covered during the course, right? That sometimes the application doesn't follow the proxy settings, so you have to fork it. So we show some techniques to fork it. You can use DNS spoofing, and modify the application itself and set your proxy in the code of the application. So if upload fails, right, you can also use the HTTP proxy environment variables. So we show a lot of techniques, like in more details and step by step during the course, because this is a very common problem in every test, right? The first thing you want to do before you run the app is to ensure that you're going to intercept all the traffic, because of course, if you hack the desktop application, normally you will hack one user, but if you can hack the API and you can hack all the users, that's going to be cooler. So you should always look for the API traffic as well, right?
Yeah, the API is totally a gold mine usually.
Yeah.
Well, awesome. Thank you again and again. This has been wonderful. There was a very, very sweet chat message that came in that I totally wanted to highlight. Stacy had said, hey, Abraham is an amazing resource. This is an InfoSec tide raising all boats, raising all ships. So glad we're getting education out there. Thank you again and again, my friend.
Thank you. Thank you for the kind words. And yeah, I hope this was fun. And yeah, maybe we'll do some other one next time as well.
Alrighty. We'll tune out, everyone, but thanks so much for hanging with us. Bye all.
Yeah, thank you, everybody.
Cool.
No more questions?
No, looked all good.
Okay, then let me stop the recording.